review a little bit about heat and temperature. First, we're going to take a look at heat flow. Usually we have particles go from hot to cold. So if you have something that's 100 degrees, like a bar of metal, and you put it in water that's 70 degrees, the metal is going to give heat to the water. So heat will go from the hot to the cold. And a few things that we want to talk about is exothermic and endothermic. Just some reminders. Endo meaning in, and thermic meaning heat. So energy is going to be absorbed. In the heating curve, that is going to have energy added in so that we're making things melt and we're making things turn into vapor. So heat is being added. And if you look at table I, take a look at table I, the values for delta H are going to be positive. Now when we're talking about exothermic, exo meaning exit, out, and heat is thermic. So energy is going to be released. It's going to be given off. So we're not looking at the heating curve, we're looking at the cooling curve. So as we go from a gas to a liquid, or as we go from a liquid to a solid, that's going to be an endothermic process. Heat is going to be removed from the system. And if we're looking at table I, those delta H values are going to be negative. And if you forget, there's a little note at the bottom of table I that tells you that exothermic reactions are negative. A few other reminders. Temperature is the average kinetic energy of particles in a sample. That is a definition. You must know that in order to be able to answer questions about this. The highest average kinetic energy is found at the highest temperature. Quite often you're given 4 samples with 4 different temperatures and they have different volumes. We really don't care about the volumes. We care about the temperature because the higher the temperature, the higher the kinetic energy is going to be. And the opposite is true. The lowest temperature is going to have the lowest average kinetic energy. And then the last little component, just to remember, that's on table T, that we convert our Kelvin from our Celsius or vice versa using this little equation here. And that's going to be really important when we're talking about gas laws.